Continuing our work in Chapter 1, Lesson 4, linear functions now in slope. Let's move on. These are the objectives. And again, you don't need to copy this part down because we'll cover it in the slides, but gives you an idea of what we're going to be doing. First of all, slope. Well, when we think of slope, we think of going uphill a slope, or skiing, going down a slope, the pitch of a roof, highway going up, going down, and in a sense, it's a ratio, as they're defining it here, of rise, which is y units, over run, which are x units. So in a graph, if we have an ordered pair and another ordered pair, we're calling these the sub 1s and these the sub 2s. If we subtract them from each other, we get a ratio. How much did it go up? How much did it go across? The formula for slope, and we usually use the letter M for it, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now remember, you can't have a denominator that is 0. Anytime your denominator is 0, and we do have that when we graph a vertical line, we say that slope is undefined. Okay, now I'm including this diagram in your booklet so you'll see what it looks like. But again, you're taking notes. All right, let's go on. For example 1, they're asking you to find the slope using these two pairs. Now here they're making this pair the y sub 2s and this pair the y sub 1s. Suppose we switched it around and had it the other way, because you see it worked out here. Let's do it the other way. So this will be a minus 2 minus minus 5, and this will be a 4 minus a minus 1 gives you a positive 1. So this is a negative 7 over 5. Now notice when they did it the other way, they got a 7 over a negative 5. What I'm showing you here is it works either way, and this is just a little bit of substitution and calculation. So our slope is this. All right, let's go on. So somewhere in your notes, I'd like you to sketch these. There's your basic graph, and then there's your line. If it starts low and as it goes to the right moves up, this is positive slope. That's saying the slope is greater than 0. That would make it positive. Now, if the line starts high and as you go to the right it goes down, that is, your slope is going to be negative. That is, it's less than 0. Less than 0 is negative numbers. So starts low, goes up, positive slope. Starts high, goes down. As you go to the right, negative slope. Now, how about a horizontal line? Well, we say that is 0 slope. And the vertical line, as we said, when we did the slope, our denominator would be a 0. Could be like 3 over 0. When our slope formula gives us this as a result, we say it's undefined. So as reference, little diagrams, positive slope, negative slope, zero slope, undefined slope. Again, this is all building up to what we will be doing as we go through this section. Now, there are a number of formulas we're using in this section, and we'll call this one here, write it down, y minus y sub 1 equals m times x minus x sub 1. If you have one ordered pair, and if you have the slope, you can actually make an equation. And this is the formula that we call, and it's written up here, point slope form. Why? Because there's one point, x sub 1 and a y sub 1, and you have the slope. So very well named. Now in example 2, they're giving us a point, and they're giving us the slope. So let me write that out for you. So m is 6, and our point is 2, comma, negative 5. Let's go to the whiteboard here. And we want to find the equation of this. Well, our form is y minus y sub 1 equals m times x minus x sub 1. And you'll need to use that a few times to practice it. Now we're going to substitute. And I'll put it in black here. That m is 6, so this becomes a 6. Now our x value is 2, but in the formula there's a negative. So this is, in a sense, becoming a negative 2. Now our y is a negative y in the formula, but our y value itself is a negative. So we put negative, and another negative here makes this actually a positive 5. Now from this we want to put it in, let's say, slope-intercept form. Y equals mx plus b, and then later standard form, ax plus by equals c. Okay, and then this b and this b is different, actually. Sometimes they use capital letters here. Okay, so let's just solve this now. We get y plus 5 equals 6x minus 12. Now, if we put that 5 over on this side, we get y equals 6x. Now, the positive 5 on this side becomes a negative 5. So this becomes a negative 17. So this now is in slope-intercept form. And if we want to put it in standard form, we just take this term, move it over to the other side, and we now get a negative 6x plus y equals a negative 17. So lots of algebra skill and being careful of the signs. Let's go back to our regular board and see what we have here. Okay, so there it is in slope-intercept form. And they didn't put it in standard form. But again, if we did, we just move this over to that side. It becomes a negative. All right, let's go on. Okay, here they're introducing the slope-intercept form. Why do they call it that? Well, because there's the slope and there's the y-intercept. So slope-intercept form. M is the slope, and the b value Whatever value is there, that's where it will cross the y-axis. That's why it's called the y-intercept. All right, let's go on. Now, I'm going to show you how easy it is if we use what we had so far to graph. I'm going back to red here. An equation. Now remember, it's in function form, but this could also be written y. Can always replace the function symbol. So there's our slope, and there's our y-intercept. So to plot this on a graph, you plot first the y-intercept, which is a positive 1. So you put a dot right there. Now your slope is positive, and remember, slope is rise over run, or y over x units. So again, there's different ways to do it. It's positive. I like to do the run first. So the run is x units, 5. So I go over 5 and mentally put a dot there. You don't really put a dot there. And then now from this point, you're going to do your rise. It's positive, so it's going to go up 1, 2, 3, up to there. And then you take your line tool, and then there's the graph, and you've plotted that using the slope and the y-intercept when it's in slope-intercept form. A dot on the y-intercept, do the run. If it's positive, it's to the right and then up. If it's negative slope, it's to the left and then up. Okay. And there is the official presentation. I did it in the previous slide. Now, continuing with our formulas, there's an equation of what we call a horizontal line. And that is simply y equals the b value. Now, often we can think of the ordered pair as x comma y, but sometimes we use a comma b, where the a would be the x and the b would be the y. So here we're saying for a horizontal line, y equals b. So it's going to be the y value as the intercept. And let's give an example of it too. It's probably best here. So we have y equals 3. Suppose that's our equation. So our b, and the ordered pair would be 2 comma 3 here. Well, what's in the b position? The 3. So if you plotted that, it would be 2 comma 3. It would be right there. But it's going to be a horizontal line because that's all it is. So then you just draw your horizontal line through that. And remember, your y value is going to be 3 at this position. And there's an infinite number of points along this line. The slope, again, of horizontal lines, just reviewing, is 0. All horizontal lines, the slope is 0. Looking at another basic equation, and again, keeping in mind that the ordered pair can sometimes be written a comma b, a vertical line, that special formula is x equals a. So if we had x equals 2, and that ordered pair 2 comma 3, again, if we were to sketch it, the 2 is right there, and our point, if you recall, was up here, and it just makes a vertical line. Didn't do it too well. And we said the slope of all vertical lines, just review, is undefined. And the reason for that is if you did the calculation, you would get something like this. Now don't put this as an answer. This is the calculation. The answer to something divided by 0 is undefined. Now here in example 4, they're asking us to graph this. Well, we did. Again, it's a horizontal line. And if you had this one, x equals 2, that would be a vertical line going through 2. Didn't do that too well. And if you're in your notes, you can put both on the same graph. Now here they're giving us an equation of a line, the general form. Now the standard form is usually ax plus by equals c. Normally on this side it would be a negative c, but this is what often is used in textbooks. Here they're just putting everything over on one side. And A and B cannot both be zeros because then you don't have any line. Okay, because out of this you can make the special equations for the horizontal line and the vertical line. All right, let's go on here. Clear this up. Okay, it says find the slope and the y-intercept of this line. So let's write it. We'll do it on the whiteboard here. You can copy it with me here. And I'm going to move that over to this side here as a 12 already. Okay, so the best way to find the slope and the y-intercept for something like this is to put it in slope-intercept form. Y equals mx plus b. So I have 6y, this 6y. I'm going to transpose the 3x to the other side as a negative 3x plus 12. Now I'm going to divide everything by 6. And I get y equals a negative 1/2 x plus 2. So my slope then is a negative 1/2, and my y-intercept is a plus 2, but we don't write the plus. Let's go back to our board and check it out, and there it is. Okay, let's go on. Now, here in our text, they give us a protocol for finding the intercepts to graph when it's in standard form. I'm going to go to the whiteboard and show you my method here. And I just want you to see where this is coming from. So we have 3x minus 2y. And again, I'm going to take this negative 6, put it on the other side as a positive 6. You can see where it's coming from. And I like for this, I'm going to go to the whiteboard here, to use what I call a special t-chart. So write this down. Put an x there and a y there. Now under this x, we're going to put a 0. Under this y, the next slot, a 0. I call this the x and y intercept t-chart when you have this set up, because this is going to give you 0, b, which is your y-intercept, and this is going to give you a, 0, your x-intercept. So if x here is a 0, 3 times 0 is 0, you're going to divide a negative 2 by both sides and get the y value is then a negative 3. So the ordered pair is 0, negative 3. Now if y is this 0, you're going to get 3x equals 6, which gives you a positive 2. So 2 comma 0. Now you're going to make a little graph, and you're going to plot these. 0, negative 3. So 1, 2, 3. There's your y-intercept. And then 2 comma 0. There's your x-intercept. And then use your line tool, and you have plotted using the intercepts. That's my 2 cents, and let's see what the picture looks like here. So there's the x-intercept, and somewhere should be the y-intercept here too. Let's see if it's on the next slide there. So there's the y-intercept, and then here is the graph. I like the idea, and again, just to emphasize, make that little special x and y intercept t-chart, and then this will give you your b value, that is your y-intercept, and this will give you your a value, your x-intercept. Again, there are different ways to do it, but I think this is a nice way and the one I feature. This slide just goes over the various formulas that we've mentioned already, and then now on to an application where they're taking example 7, 2 data points, finding the slope, then taking this slope, putting it into the point slope form, and they'll want the slope to 3 decimal places, which they have here, and eventually the b value to 1 decimal place. So let's take a look at that. They've put it into the formula here and eventually end up with this. Now, I could work through the computation here, but again, it's just figuring out and following what they said. So the function models the average global temperature for the atmospheric carbon dioxide in this many parts per million. Now in the last slide, they said, use the formula to project the average global temperature when the concentration is 600 parts per million. So now you're going to take this 600, put that for the y. In the x value, you're going to put the 600 there, and then just do the algebra, well, it's arithmetic now, and you end up with 61.6. So when it's at the concentration of 600 parts per million, would be 61.6 degrees Fahrenheit. Okay, so lots of stuff. I don't want to keep this too long. Hopefully your booklet's helpful too. Take the needed notes.